Good evening, students. So let us move on to the next topic, which is speed, slip, torque characteristics. So in this graph itself, we will be studying two characteristics. The first characteristics is about the speed torque and the other characteristics is about slip torque. So there is a relationship between slip, speed and torque. As we have already seen the derivation of the torque of the three-phase induction motor. So in the derivation we derive the torque expression as 3 upon 2 pi ns s e2 square r2 upon r2 square plus s x2 square. So this was the expression for the torque. So from the torque expression we can easily find out that torque is directly proportional to slip, but torque is inversely proportional to ns, and ns is nothing but the synchronous speed. Ns is nothing but the synchronous speed. So it is directly proportional to the slip, but it is inversely proportional to the speed. So we can see over here, when we move from left to right, then it denotes the torque speed characteristics, and from right to left it denotes the torque slip characteristics. Okay, so in the torque speed characteristics we can see when my speed is 0, my slip is 1 and my torque is also 0 over here. Okay, no, torque is 1 means is proportional to the slip, and when my synchronous speed, when my speed is maximum, my slip is 0. So here my torque is also 0. So torque is proportional to the slip, but torque is inversely proportional to the speed. Torque is inversely proportional to the speed. When my speed is maximum, it is a synchronous speed. The rotor has attained the synchronous speed. The torque is 0 and also the slip is 0. So this is the graph of slip torque and speed torque characteristics. Now this graph is divided into three regions. The first region is the motoring region over here, from 0 to ns speed. From 0 to ns speed is the motoring region because the maximum speed is the synchronous speed over here. And the next region is from ns to ns, and which is the generator region. And if we go to the negative side, it is the braking region. If we see in the terms of slip, then from 0 to 1 is the motoring region. From 0 to 1 is the motoring region, and from 0 to -1, when the slip decreases from 0, when the slip decreases from 0, it is the generator region. And when slip is greater than 1, from 1 to 2, it is the braking region. It is the braking region. Okay. Now, in the motoring region itself is divided into three more regions: the low slip region, the medium slip region, and the high slip region. In the low slip region, the slip is very small. Here, slip is very small. This is the low slip region, but my synchronous speed, my motor is moving with the synchronous speed at this time, but slip is very small. So let us jot down the three regions. In the motoring region there are three regions. So first is the low slip region. Low slip region. Okay, this is the first region. In the low slip region, my slip is very much less. My slip is very small. Slip is small. So when my slip is small, I can neglect this. So my torque is equal to K. I can put it as K S E2 square R2 upon R2 square. I can neglect this part because my slip is very much small. I can just neglect it. Okay. So my R2 gets cancelled, and my torque is directly proportional to slip over here. So it forms a straight line. So it forms a straight line. So it forms the straight line. You can see this straight line. This region is my low slip region. This region is my low slip region. It forms a straight line. Okay. Now the second region is the medium slip region. Second region is the medium slip region. Okay. This is the low slip region. This is the medium slip region. Okay. So the second region is the medium slip region. In the medium slip region, I can consider slip in the picture, and I can neglect this R2. I can neglect this R2. Okay. So my expression for the torque will be torque equal to K S E2 square R2 upon S X2 whole square. So from here, or I can write both the squares with them itself. So my one of the S gets cancelled. So my torque is basically proportional to 1 upon S. So it forms a rectangular hyperbola. So it forms a rectangular hyperbola, this region. Okay, this region forms a rectangular hyperbola. It is somewhat like that. Okay. So over here it attains actually the maximum torque. It attains the maximum torque. So this can be also given as T max. And this maximum torque is also known as the pull-out torque or the breakdown torque, because as the slip increases more, eventually my motor stops. So the third region is the high slip region. So the third region is the high slip region. Slip region. So third region is the high slip region. In this region, what happens is that my S is very much greater. My S is very much greater, and as it comes and as it crosses beyond 1, eventually my motor stops and it comes out in the braking region and it comes down in the braking region. So my motor stops. Eventually, my motor stops and comes down in the braking region. So in the braking region, my slip is greater than 1. The braking region, my slip is greater than 1. But when it comes down in the braking region, my speed is also goes in the negative. Why my speed goes to negative? How can my motor comes in now in the braking region? The motor can come in the braking region if I'm having the 3 terminals. We are having the 3 terminals of the 3-phase induction motor. If any of the 2 terminals are interchanged, leaving one aside, if any of the 2 terminals are interchanged, leaving one aside, then it forms plugging. Then it comes in the condition of plugging. Plugging is nothing but reversing the magnetic field. So what happens is that my magnetic field gets reversed. My magnetic field developed gets reversed and it starts developing in the reverse direction. Okay. So what happens? My motor eventually breaks down, and also my speed crosses the zero value and goes into the negative value. and goes into the negative value, and my motor breaks down. Okay, so that's why this maximum torque is also known as the braking torque or the pulling torque, pullover torque. Okay, it is also known as the breakdown torque. Okay, so and if my slip is decreased beyond 0, my motor only operates in the slip region 0 to 1. If my slip is decreased beyond 0, my motor starts working as a generator. My motor starts working as a generator. So it is a generating mode over here. And the speed, maximum speed, synchronous speed attained, it crosses that and attains 2ns. From ns to 2ns region, it is a generator region. So for this, it is supplied with a constant frequency source. The first condition for this is that. So when the stator is fed with the constant frequency source, it starts working in the generator mode. So these were the 3 regions depicting in the speed torque characteristics, or we can say the slip torque characteristics. Speed is increasing in this manner and slip is increasing in this manner. The different regions explains the different slip values. But my motor only works in the region when my slip is from 0 to 1. And this motoring region is having 3 regions more. The 3 regions are the low slip region, high slip region, and the medium slip region. In the low slip region, it is torque came out to be directly proportional to S. So it is forms a straight line, which is depicted over here. Okay, and in the medium slip region, my torque came out to be inversely proportional to S, which is depicted with the rectangular hyperbola over here. Okay, and then the high slip region, S is very much greater, and the motor eventually stops. This is the high slip region, this is the high slip region, and my motor eventually stops and enters into the braking region. Okay, yeah, and in the generator region, my slip is from 0 to -1. What is this torque? This is EST. This is the starting torque required, because starting torque is very high over here. See, the starting torque required is very much high. So when my synchronous speed is 0, my slip is 1. At the starting, always my slip is equal to 1. So whenever the numericals come and they ask the value for the starting torque, we can directly put the slip value as 1 over there. So at the starting, my slip is 1, but my synchronous speed is 0 over here. And at that synchronous speed, my torque developed is said to be as the starting torque. It is said to be as the starting torque. Okay, so this was all about the characteristics. These are very much important from the exam point of view. The question definitely comes from here, that what is the starting torque, or derive the expression of the torque, and also draw the speed, slip, torque characteristics. So this is very much important from the exam point of view. Okay, so this is all it, and please subscribe my channel, please share my videos, and if you have any doubt, you can ask me in the comment section. Thank you.